Okay, so good morning everyone. My name is Wojtek. I have been part of the UPAC community for just about a year. Although I have been flying PPG, actually the just the paragliders for several years, since probably '92. The PPGs, basically powered paragliders, I've been flying just for several years. So the always exciting thing about flying these things is just air always in your face, I guess. But sometimes a bad thing because when it's cold. But it also is very simple device. The problems with the engines, engine quitting in the mid-air doesn't cause much issues. You can land pretty much anywhere. It doesn't really diminish performance of the wing or anything like that. So it's actually quite safe. Although I do have a reserve chute on it, so it just makes everything a bit more heavier but just in case something would go wrong, always a second chance. For many years, I always wanted to build my own, so there's many of them out there, but prices are, I think, kind of steep for just a simple piece of device like this. So I always wanted to build my own, but choosing the engine is kind of difficult because either they're too heavy, they don't have enough power, or combination of two, I guess, and so it's always a challenge. And this is actually my second build. First one I built on just a two-stroke KT100 motor. I don't know if anybody knows them from the Go-kart racing. They used to be really popular, but they're kind of obsolete now, so you can still get some parts in States, and so I didn't want to pursue that route anymore. So I decided to look for something else, and there have been a number of conversions basically on this engine. And I just want to talk a little bit about this engine. This is essentially a Honda GX200 engine. Fancy pointer. This guy here is a Princess Auto clone. It's if you search the web, you can just type something GX200 clone, and you'll get like many flavors of these. And basically, many stores will, I guess, buy them from China and just put their own name. So this is the Powerfist model, but they're all basically the same. But if you compare them to the Honda, parts are interchangeable. It's essentially clone version. Everything is the same. Bolt patterns, castings are very similar. However, Honda is built a little bit better. You can see easily from just the castings. They're smoother, and people are saying that overall they're better. The crankshaft's better. I guess balance probably stronger as well. But when I did my conversion, there's actually a number of parts that we have to change. So at the beginning, I think if you're just experimenting, clone is I think because it's very affordable. I think it's a good choice. So yeah.
Is the 200 the spike?
Sorry?
200 cc's?
Yes, they call 200 cc's, but they're actually 196. So why clone or GX200 even Honda GX200? Obviously very affordable. Parts are widely available. You can go even to the Honda dealers, and they have the parts. However, it's kind of it's hard to deal with them. They do add a little bit of markup on the price. So and they always want the engine number. So I don't really deal with them too much, but you can still buy them. So proven performance. This engine has become very popular in the go-kart community, and it's more and more they use them for racing, and they build them, build them stronger, and so they seem to last pretty well. There have been a number of conventions in England. Even the company called Bailey Aviation, they built probably the only 4-stroke PPG engine. They actually attempt to build a kit for conversion. And there were actually parts available, but I have checked recently, and for some reason they discontinued it. So I don't know why, if there was some issues or complaints, or it was a direct competition to their other engine, which is very expensive, so who knows. For the application I'm using, obviously there's benefits of the 4-stroke. It is smoother running, and it's actually very efficient. For me, just the cruise, keep the level flight, it burns around 2.5 liters per hour, so I think that's pretty good. And it runs on a lower RPM than my other 2-stroke, and most of the 2-strokes that are out there, so I think it's all good. So here I just want to give you the list of things I had to purchase. Some prices there, it's not it's kind of from top of my head. I didn't really look at all the receipts, but so certain things you have to change. Okay.
What's the difference in cost between the Honda engine and the clone?
Oh, I forgot to mention that. Yes, clone basically in Princess Aero, when it's on sale, and I suggest buying only on sale, it's $100. Sometimes, yes.
$100?
$100. Sometimes they even drop it to 90. Honda is, it's hard to get it cheaper than $450. So, big jump. And as you will see, there's many parts that are changed, and even sometimes what you can do is buy clone, so you'll have a casting and a cylinder sleeve, and you can change the, for example, crankshaft, and most of the other parts are changing.
And are these prices the clone prices, or
those are actually performance prices, performance parts prices. So those are very good parts. That's what the racing community uses, and they behave pretty well. So connecting rod, it's a billet type connecting rod. So it's basically CNC machine, $60. I think is a very good deal. It actually comes with the bearings. Even Honda connecting rod doesn't have bearings, just a casted connecting rod, which is milled. And as soon as that it wears out, the connecting rod is garbage. This one you can just swap the new bearings and off to the races, I guess. Piston, $25. This is the genuine Honda piston. Camshafts. The one I used, $50, but there's many flavors of camshafts. We're gonna look at them in more detail, but you get range from $50 to $150. So depends what you want. Flywheel. I really recommend changing flywheel because we have some pictures, but the original flywheel is cast iron flywheel, heavy, bulky. We don't want that. This is aluminum, weighs only 1.8 pounds, so very light, very good. So for the top end, head, so this is GX100. It's a smaller version of GX200 Honda. I think it's got a little bit smaller displacement, but what's a big difference is combustion chamber in the head is much smaller. So basically the GX200 GX200 or clone combustion chamber is 22 cc's. The GX160 is 14 cc's. So just by changing the head, you're gaining performance right there without doing anything else. Stainless steel valves. Oh, just one more thing about the head. People do get away without changing the head, basically keeping original head, just melting the head down, 65 thous, somewhere around there, and it proves to be okay. Also okay, obviously not as good, but that's actually I'm going to try to do my next project actually using the original head which I have from this engine, and and see what difference do I get. So stainless steel valves, as you can see, 30 bucks for two, very good price, and it is recommended to change them. They last way more longer, plus they do allow better flow of the air because they kind of ground nicely, so they're overall better valves. Rocker arms. I kept the original rocker arms. You can get the basically performance rocker arms, and they I think quite expensive. They start probably from $150 and go up to even like something like $250. And you can get them in a different ratio. Mine are just a 1-to-1 ratio. You can get them in 1-to-2 and I think 1-to-3. Again, you gain performance just by doing that. So, but I'm using just the standard rockers. For now, everybody's saying that I should change for the better ones, but I know people use them, and so they seem to be okay. Springs, definitely have to change springs to, so they cheap 16 bucks to at least I think like 26 pound springs. Original ones are I think like something like 8 pounds, so very light. High flow exhaust, so this is something that you probably want to manufacture yourself. I just bought some tubing and just welded things together. Racing car. I'm currently using Volvo, although I'm not a big fan of them. But lately this carburetor started to run better on me, so I'm kind of okay. So, but I was really frustrated about it. But Mikuni, I don't know if I say that right, but those are very good carburetors. And the only thing is you have to always stay with jets. There's some guidelines online, like what jets to use, but it comes down to you, I guess, buying the set of jets and trying what works best for you. Basically, get that air fuel mixture right, so it runs good. Also, people are saying that these carburetors don't behave as well with the change of pressure. But I don't know. It's I guess all the carburetors you guys are running is not adjustable, so they I guess behave correct. So I don't know. I would have to take that. Cylinder head studs. Yes, I do recommend installing those. I didn't, and I had some issues because of that, and I'll show you that later.
Are all these parts go-kart performance parts?
Those are all go-kart performance parts, and it's
something you can find on internet?
Yes, I do have some links at the end. So there's one good guy in Windsor that has pretty much everything, although he does add a little bit of price on top of what you find in the States, but again, it's kind of more local, so it's I guess sometimes worth it. But what I do sometimes is I just order a whole bunch of stuff, I ship to the border. I don't know if you guys do that, and they drive like up to Niagara or whatever. So you can at least save a little bit of shipping.
So you've added $500 to the price of the engine.
Oh, so I guess you did quick math. Yes. So I talked about the milling the cylinder. Well, that's free if you have access to the equipment. The other things, obviously, first thing you do, you remove the governor, remove the low oil sensor, change the throttle linkage, add the obviously better filter, fuel pump. So yes, that's what I got into this engine. Okay, so we're gonna go right now to the more details into the how. I took some pictures. I'd like to also thank Robert for helping me out on this. Okay, so you can see here, this is that new connecting rod. It's very nicely machined. And And a couple of benefits between this one and the stock one. This one has a hole right here that goes right up and provides the oil to the bearing. And what happens when the crankshaft spins, this I guess needle, whatever you call it just basically hits the oil. And there's that small hole and just injects the oil into the bearing. So that's how it basically keeps the bearing lubricated. Some things like that is not with the stock connecting rod. You don't get things like that. It's just in the stock one, you just have a hole in the back here, and that's how the oil gets moved. So I think this is way better design.
That means the engine has to always set that way pretty well. Not like too close.
Well, technically, but I kind of the oil here is filled up to about here, and to get the oil out of this, you also have to, like, engine almost has to be flat. You know what I mean? So I don't know if that'd be issue for you. Even for me, when I get up and I lean forward, that still even keeps this in the oil, because I guess the design of the the whole compartment here, it's basically even though you lean forward, the oil doesn't really flow anywhere too much. So I don't think that's the thing. That would be an issue. Okay, so those two holes, that's where the low oil sensor was. Obviously, I just got rid of it because I guess it's up to me to check the oil before I fly, and I don't want this maybe to cause the engine to shut down or something in midair. So I just threw it out. And actually, the wire from this goes right here, and there's the bolt that actually installed basically just to seal the chamber. In here behind the crankshaft, there's the governor, which all you do is there's a snap ring, you slide the governor out. And also what I did on the crankshaft, on the other side, there's a sprocket that drives it. So all I did, just heated up the sprocket, pull it out, so just reduce a little bit of the weight. I guess you don't have to do that. Okay, another thing is piston. The original one, I guess the quality might be good, but you can see it's a dish piston. So and you're going to change to the flat top piston. Right there, you're increasing the compression ratio and gaining the power. So this is the stock camshaft. Aluminum sprocket. I do have, I think, on next slide some comparison. Yes, so I don't know if you can see it. So this stock, and you can see, look at the cams here. Those are two performance ones, and you can see the much bigger duration on these cams than on the stock ones. So obviously that's where you gain. It's gonna allow more air into the engine. I don't know what is the maximum lift on the stock one. This one is 308, so that's this guy. And this one is Black Mamba. It's a guy that in California, he makes them, and he priced them really well. For this one I paid $100, and I wasn't happy with the performance. For this one I paid $50, and I think it runs way better. So, and even because what they do, I think they weld the lobes here, and then grind them, and I think then they harden them. I don't know exactly what the process is, but just by looking at those two cams, this is way better. So I really recommend this guy, and I do have a link at the end to show you this, so you can find it. This here at the bottom is basically an automatic decompression valve.
Can you speak up a little bit?
Sure. Automatic decompression valve unit, basically when the engine revs goes above I think 500 RPM, it this moves down and it allows because what it does, it just pushes the exhaust valve a little bit on the compression stroke. So basically it just goes down and that doesn't happen anymore. It does provide better starting performance, so it's easier to start.
Wojtan, there's a microphone on the podium if you want to use that.
Check. Okay. Okay, so here are the flywheels. So good old cast iron, very heavy, and this thing you probably don't want to spin more than 5,000 RPM, probably dangerous. So this is the one I have installed. It's a very nice performance flywheel. It's a billet. It's a machine from a single piece of aluminum, so it's very strong, very light. I highly recommend. And there's actually many flavors of these. You can buy these with fins. So as you can see right now, there are no fins to cool the engine. So I use the stock fins, which are like a plastic disc with fins, and you just bolt that onto the flywheel. And you can buy the flywheel with like a machine fins, so you don't have to. You can discard the plastic ones. And so this is the second generation of flywheels. The first generation was a bit heavier. There was, if you would look from the inside, it was more aluminum. So they managed to now machine it a bit better. So just get rid of more material. Okay, so this is just the original head. I do have, I think, a comparison on the next slide. Yes, so this is a comparison of the original head, so GX200 clone, and this is GX160 head. So you can see the combustion chamber is way smaller. It's 14 cc, and that's 22. I also machined this head down by 65 tau, so that even increased the compression ratio. So.
What fuel do you run that higher compression? Do you have to run high temp fuel?
I just run the 91 octane pump gas. Although after the yesterday presentation, I guess I will look for the ones without methanol. I was under the impression that 91 is everywhere without methanol, but I guess that's not the case. So here's the comparison between the valves. So this is a stainless steel valve. So you can see nicely machined here. It does provide better airflow. Those are just the stock ones. You could try, run with the stock ones, but for the price, I think it's worth just changing it. Just a comparison of the springs. That's the stock spring. This is, I think, 26-pound spring. So you can see it's longer. You do have to check for the spring bind, but unless there's head is badly machined or something, that shouldn't be an issue for the 26 pounds. I know if you try to run even stronger springs, like 40 pounds, or they even install like a dual springs, that's when you might get into a problem of clearance issues. And those are a whole bunch of parts that you probably could just sell on the eBay or Kijiji and even offset the project even more. So you can see this is the stock connecting rod. It's a very weak component. It's just a casted aluminum, so that makes it even worse. So this is the complete engine, as you see there. It weighs 16 kgs. It's not bad, I guess, but I still want to shave a little bit off of weight. So although that engine is exhaust, I think I could, this part I could make it a little bit lighter. The back mounting plate, you can't see it here, but I have it made in from sheet steel. I think it's a 1/8 or 3/16, I can't remember. So I'm planning to make that from aluminum, which probably is going to be stronger or even stronger and lighter. What else? This the babies I was talking to you about, they actually, see, I have it like a bolted, the reduction drive is bolted on those 4 bolts. But they actually made, I kind of looked into what they did, and they actually made the whole that cover and the mount for the pulley. Again, they basically CNC'd that. So basically one piece. And I think it's a very good idea because you obviously gain a lot of weight. You don't have to a big piece of aluminum which weighs a little bit. So I don't know, maybe it's not really a big problem for application like aircraft application, or for me, ever I guess, ounce counts. So,
what's your reduction ratio?
I think 2.4 right now. We get to that in a second because I was a bit playing with the reductions, and so I think that's what it is from what I remember. So there's just a few more shots of this just on the frame. And here's in the corner here, there's a KT100 sitting. So this is my first project. So still runs, I still fly it. Just on the side. One more. And okay, so this is the prop. And it's 48 by, I think, 15, because I actually had to measure it myself. The reason is within like PPG community, they don't really give you the spec for the pitch. They just give you, okay, this prop is good for this type of motor. And many times you ask them, okay, what's the pitch? Oh, I don't know. You know what I mean? So it's kind of hard to find the correct prop. And so I did some measurements, and it turns out that this prop is, I think, too fine for me. And I did find some manufacturers that actually they do provide pitch, even though they recommend for a certain type of engine, but they also provide the pitch. So there's obviously one guy, GSC props. They can buy them even for PPGs, and obviously ground adjustable, so you know exactly what the pitch is. Although I didn't go with that option, it's because it's a bit heavier. Now, on my other PPG, I do have a GSC prop, and it's about 700 grams heavier than, than this guy. Okay, so some specs about the engine. So yeah, bore stroke, so total displacement 196, combustion chamber volume is 13 cc's, so originally 14 cc's, and that's what I machined down. Gasket 4.5 cc's, basically you measure the thickness of the gasket. Now, when I probably would do it right now, because that really gets your spark plug really close to your piston. So I even have to have a small shims to bring the spark plug higher, so there's no interference. So I will probably machine it a bit less, and then play with the gasket here. You can get the different thickness gaskets. So I guess it's better that way, because obviously I can't make up the material. You can always melt down, right? So I think right now that's what I have. That's my compression ratio from the stock 8.5. It's a huge difference, and horsepower. It's I don't have equipment to actually test it, but I do have a piece of software which is freely available online, which you can play a little bit with it. You can. I think it's pretty good. You can plug all the numbers. You can have detailed information about the heads, about your belt timing, and it can give you an approximate horsepower and your curves. So even if it's, I'm sure there's an error in that, but at least it gives you opportunity to you can kind of swap the parts and see what happens. So it's a good tool to play. So yes, so right now this is the reduction 2.6 to 1. Well, no, I think that was the old one. Okay, let's see some. Okay, we have some test data here. Yeah, so with this prop 2.6 to 1, so that's what I was getting. Engine rating at 722 RPM. That's how fast prop was going. And around 39 kgs. I just put the scale against the engine and kind of measure the thrust there. But obviously, it's not. It bounces a little bit back and forth. So I can't really say, okay, that's dead on. So I would have to build something, better, so I would get better numbers. But even from the software simulator, I knew that I'm going over the power curve, so I'm on like a decline. So I figured, well, I guess I probably should have a better higher pitch prop because I'm driving this engine very high. So as you can see here, I made the bigger pulley, so it went to 2.4 to 1, same prop. The engine RPM dropped, and obviously I was able to increase the proper RPM, and so I got more power. So it actually proves that that software did kind of work. So basically, right now I tuned it more to the power of the engine, and even with this, I think you should be able to. You should probably even go down because that's probably where the top power is, and during the static test, I think you want to be below that. So. And it was significant gain in power. I did before, I was taking off, although the takeoff was kind of slow. Right now, I don't even have to apply the full power; it just brings me right to the air. So I was telling you about the stats. So I kind of did because it's kind of hard to get. Those are metrics, and it's kind of hard to get them locally, like in a local stores. So what I did, I basically got the bolt, cut the head off, and basically used that as the stud. Although they are better than the threaded rod, but not strong enough. And eventually, the temperature change and all that. This because this one gets hottest because it's at least cooling here. It kind of got loose, and you can see the gases started to just basically gasket right here. But it's funny because it happened on a takeoff, and I was like, it was very sluggy. But I did manage to take off, and but I was gaining altitude very slowly, and but eventually kind of in the air, okay, it flies, but I'm like, oh, I think my curve rate adjustment is really bad or something, or running the ridge, or because it ran really bad. But after landing, I realized, okay, so that would happen. So, but changing the gasket on these things is pretty simple, and I was off to the races pretty quick. So that's pretty much all I had. Here are some resources. So this is the Canadian side. This guy is in Windsor. He's got a pretty good selection. You can check that. Affordable go-kart parts. Very good selection, not the cheapest prices, although he has many how-tos,
He's got to go to Spain.
Sorry?
Spain, bolts in Waterloo.
Stainer?
Stainer.
Really?
They're the nut and bolt came in Ontario's one.
Really?
Yep.
I always go to bolts and nuts in Cambridge.
Stainer is bigger than them, and a lot of these guys buy from Stainer.
Really?
Yeah.
Oh, okay. Okay, good to know. Yeah, I'm gonna have to check them out.
They're on Victoria Street in Waterloo.
In Waterloo? Okay.
Yeah,
Okay.
just, west. Prince's used to be just down the road from them years ago.
Oh, I see. Okay. So yeah, these guys are very good. They have many how-tos. You can actually write to the text there, and they do answer your questions. Obviously, it's all go-kart related, but I guess if you ask the question correctly, they'll know how to answer. Small engine cams. That's the guy that does these cams. I think he probably has one of the best cams and very good prices. Arc Racing is another good site with many selection of items or parts. And I also do some shopping at Comet sale. Also very good price, like fuel tanks and all that. It's fuel pumps, even carburetors. They have good prices. Other resources. So this egg motor from UK, it's a bunch of guys that did the conversions. Some of them, they did the conversions on their own, so made their own reduction drives and everything. Some of them actually bought the kits from the Bailey's Aviation and went that route. So it's a very good site to take a look at, and you can learn a lot of stuff. Recently, because there's another flavor of those clones. It's a 212cc. They call them Predator. It's a bit more displacement, but I guess it allows to run them directly from the shaft, so you don't have to install the reduction drive. There have been attempts on this one to put it directly on the crankshaft, but people weren't getting enough thrust, so that didn't work out. But this guy, he claims he's gaining around I think 100 pounds, so directly from the crankshaft. So I guess that's not too bad. So I'm also checking this guy out, and didn't have much progress lately, so I don't know what's the story. And obviously, Google is a good resource, and there's plenty of stuff. People, especially in States, they play with those engines a lot, and if you just type GX200 clone or Sun Racing, and you will get tons of information. There's forums that people talk about it, and yeah, it's tons of stuff. Okay, that's it. Any questions?
A little bit about the reduction drive, like what bearing you use and belts and stuff.
Sorry?
What bearing is in there? And
okay, so there's two. It's basically those are roller bearings. Two bearings, two roller bearings. The reason I went that route is kind of the industry standard in PPGs. The acceptable, the side load on these bearings is it's much more than what this equipment produces. So I think it's.
they don't take much side load or the thrust.
Well, this you can purchase those bearings with I think they call that deep proof, which they do provide significant side thrust. So you have to check the specs of the bearing that you buy. So.
Well, what about end plates? Are thrust washers on it then, or what?
Thrust washers?
Yeah, to hold it.
So the way that it's machined, so the bearing goes from the back,
Okay.
and so you always push. So because it's the pusher, so it always pushes the bearings in. So you know what I mean. So I don't need any thrust washer or anything like that. I do have a snap ring on the end, so you know, just in case you want to pull the other way. But is that what you meant, or?
And you use poly V belt, right?
Yes, this is a poly V belt. It's I think it's a 14 groove. What people, the spec is about 1 horsepower per groove. Although I've seen people basically make less grooves for, you know, just weight purposes, you know, to be lighter. Obviously, you sacrifice the life of the belt. And I think the another advantage of the, at least for my application of the poly V belt, it's obviously gives you a little bit of slip. So I think it might be, you know, if we start talking about the, you know, torsional resonance and the vibrations, and I think that would help to reduce that.
That's all there is the belt. Nothing else for torsional, the resonance.
There is nothing else.
I was going to ask, how many hours do you have on this engine?
So currently I have about 20 hours on it. So I think it's not bad. Beside that head gasket, which kind of it's a parts issue, and other than that I can have any other problems, and you know, and I think engine is running better and better. And, at least at the beginning it was kind of rough, but you know, it could be just badly adjusted carburetor, or not yet broken in. So right now I think it's running fine. And all weekend, if you saw me flying, that's what I used to fly. So.
What thrust was this one flying?
So thrust? Yeah, I think I'm getting around 45 kgs right now. So it's acceptable for my application. Although if you go to that egg motor place site, there's guys that were getting, I think, close to 50 kgs of thrust. So.
Can we hear everybody outside?
Sure.
That'd be great.
All right.
Has anybody used them on an airplane yet?
On the airplane, I haven't really seen it.
Yeah.
But there's actually, if you follow this site, there's some of the links to the there's the guys that play with the Briggs and Stratton, the V engines. There's a big forum.
I think you're referring to me. I'm Pete Harrison, and I put a couple of the Princess engines. I actually bought them from NR Racing. I didn't see any reason why you couldn't put a small motor like that on Blaze Air. The original flew with 5.5 horsepower each. I got a set of props from GSC out west. I thought they'd swing they're torque engines. They put the biggest end of the unmodified engine torque is about 2,600 RPM. So I thought by hanging a big prop on it, there's a site on the computer there that it gives the amount of thrust per RPM per horsepower. And kind of going by that, a 42-inch prop, I think with about a 20-inch pitch, would give about 50 pounds thrust. So anyway, I got these props and I got it fully in running on. This is a Princess $149 motor that I was working with. So I put this big prop on, and of course, the mass of the prop, it was a heavy thing. I can't remember what it weighed, but probably over 2 pounds. The motor didn't have enough torque to wind the thing up any more than about 1,400 RPM. It would just run on that. So anyway, I'm thinking, well, I had a set of props on my Blaze Air. They were 31 by, I think, a 10-inch pitch. So anyway, I hung one of them on. And that would wind it up to 4,200 RPM. Well, that's not enough thrust to prepare them to fly a Blaze Air. You need somewhere, those props somewhere up over 5,000. So I fiddled around with it a little bit, and I think I got that motor up to maybe 45 or 46. set it on the stand in the barn, filled the gas tank on. I didn't do anything to it. I took the muffler off, put it straight back on. That's all I did to it. And with that little gas tank on top, it's not quite a, what is it, liter? The old original tank. Anyway, whatever. It wasn't very close to a gallon. But anyway, it ran for an hour and 20 minutes on that one little tank. So, you know, if I could get it throttled, it would give me a little more thrust. And drop that 4,600 RPM down where the torque is. Maybe it did work. But anyway, the long and the short of it is I'm not a mechanic, but anyway, I got on that site there, both, I discovered egg motor and also the YouTube, not the Predator one, but anyway, the Clone Racing. Checked their sites and they've used these little motors to run their go-karts and they fine tune and so on and so forth. Well, anyway, I got another set, props, 12 by, I think they were 12 34s, and I put them on these NR racing motors, and they were modified. They ground the key down to advance the timing, I think 8 degrees. Heavier valve springs. And I think that was really basically all they did to it. And they would spin those props at finally about 4,700, 4,800 RPM. And I put a spring scale on the plane with the 2 engines running, and I got about 100 pounds thrust. The biprops on the Laser, I was only getting 95, so I'm getting more thrust, static thrust. So this thing should fly. Weight-wise, the cell on the Laser, you guys aren't familiar with Lasers. This is the motor, the cell that the Rotax motors are on, and they're 9.5 horsepower. Anyway, I put the motor, these NR racing motors on the cell, made my own brackets up for it. And it weighed 42 pounds, just over 40 pounds. And the cell with the Rotax motor that runs the was flying with was about 36, so each engine was about 4 pounds heavy. They were extended, but my brackets anyway, they were extended a little further ahead, so they put the CNG on that. I moved the seat back a little bit to counter that. Anyway, I flew about 10 hours. And the only reason I quit was when I was doing a run-up, the next time I went to fly it, I flew over the course of a couple of months, I guess. The one engine didn't come up to 4,700 RPM. The takeoff was 45, and I flew around. But it was getting on towards the middle of summer. My other engines were good. Losing too much time, actually. I put my other engines on. I haven't done anything with 2 years or 3 years now. I think that was 3 winters ago. Is that right? But that helped. Then fiddle around with it. Fiddle around with it. But they'll fly and they'll work good. They only take half as much gas. The props is 34 12s. And they were heavy props too. People that make them a lot later. In fact, I took a set of props. To end in the hopes that over the winter we
okay, just a reminder, the convention is not really over yet.
try a bigger prop, bigger prop, try to evade the drive. I think it can be done, but I'm not sure. I don't know if anybody wants to take it.
You mentioned that you filed the key, right?
I did.
Okay, so something I forgot to mention with the new.
Can you use the mic?
Sorry.
Can you use the mic?
With the flywheel, this. Okay, with the aluminum flywheel, you don't have to grind the key anymore because it's already advanced.
I also put aluminum flywheel.
Oh, you did?
Yeah.
Okay, but depends. Here's the thing: depends which aluminum flywheel you put on, because this is already advanced and some of them are not.
These didn't have an advanced.
I see. So you just have to be careful because this is already advanced, so you don't want to advance more than this because it's not gonna basically run. And it's kind of weird how they refer. because they refer that this is advanced 8 degrees. But it's advanced 8 degrees from the stock flywheel. So it's actually 28 degrees.
Is there magnets in the flywheel?
Yes, the magnets are right here. So this is the magnet area right here.
Yeah.
So, and you can actually buy just like a kit that so you can ground adjustable advance. So you can move the coil up and down. So even if you want to play just with that, but that you have to buy this the second generation of flywheels.
It's fixed advance.
Sorry.
Fixed advance.
Right now it would be fixed, but you can buy a kit that would allow you to change it.
Yeah.